Hi everyone. In this video, we'll solve another real-world business problem using SQL Server. Our goal? To find products that had 10 or more orders in 2 consecutive years, and compare 2 methods for solving it. Here's our orders table. Each row contains an order number, product details, shipped quantity, unit retail price, and an order date. There's no primary key here, so the table can have multiple rows for the same product in the same year. The business wants a report of all products that were ordered at least 10 times in 2 back-to-back years. We'll return the product number, part number, the first year and its order count, and the next year with its order count. For example, here's a sample output. For product number 11500, part number 10019, it had 27 orders in 2021 and 26 orders in 2022, so it qualifies. Let's start with method 1, using common table expressions and self-join. First, we create order years to extract just the year from the order date field. We convert the date from its numeric format into a proper date, then apply the year function once, keeping our code clean. In the second common table expression CTE, we group by product number, part number, and year, and count the number of orders in that year. This gives us a small aggregated table with 1 row per product and year. Then comes the self-join. We join the table to itself on matching product and part numbers, and where 1 year equals the other year minus 1, ensuring they're consecutive. Finally, the where clause checks that both years in the pair have at least 10 orders. The result is sorted by product number. Running this query returns 17,878 rows, and it takes about 3 seconds to complete. That's not bad, but we can make it even faster. Now let's see method 2. Common table expression plus lead, window function. We start the same way with the order year CTE to extract the year. In the second CTE, we still group by product, part, and year to get the order count. But now, we use lead to look ahead to the next year and also get the next year's order count in the same row. This means each row already knows its consecutive years information without a separate join. In the final select, we simply filter where 1. First year plus 1 equals next year, ensuring years are consecutive. 2. Both order count and next order count are at least 10. That's it, no self-join needed. When we run this query, we get the same 17,878 rows, but it's almost instant. Let's compare the performance side by side. Method 1, about 3 seconds. Method 2, about 0 seconds. Why? Because lead works within the grouped results set in memory, avoiding the extra table scan and join that method 1 requires. Fewer operations means faster execution. To recap, method 1, self-join after grouping, clear, but involves more work for SQL Server. Method 2 uses lead to compare consecutive years without a join, cleaner and faster. Whenever you need to compare rows within the same group, consider using window functions like lead or lag for better performance. Now it's your turn. Try both methods and see the performance difference in the data. And don't forget to explore more ways to optimize your SQL queries. Thanks for watching. If you found this video helpful, please like, comment, subscribe, and share this channel. Thank you.